Have you ever pondered the marvels of robotics and how they impact our daily lives? From the manufacturing industries to our homes, robots are revolutionizing the way we live and work. This is the dawn of robotics, an era where machines are not just tools, but partners, assisting us in tasks both mundane and complex. In this world where technology is advancing at a breakneck pace, robotics stands out as a field that is not only fascinating but also increasingly relevant. It's a world of untapped potential, where the line between science fiction and reality blur. Over the next few minutes, we'll delve into the captivating domain of robotics, exploring its roots, its current state, and its future. We'll guide you through the process of creating your very own robot, from the simplest robot arm to an autonomous machine that can sense and interact with its environment. Stay tuned to discover how you can bring these fascinating machines to life in your own home. Scene script. Ever wondered how a robotic arm works? Well, today you'll build one yourself. Let's begin with the basics. A robot arm, in its simplest form, is a series of joints and links powered by motors. Now, to construct our very own, we need a few household items. A couple of cardboard tubes, some string, a few rubber bands, and a handful of clothespins. The cardboard tubes will serve as our links and joints. Cut them into varying lengths to simulate the different parts of an arm: the upper arm, forearm, and fingers. The string will act as our tendons, allowing us to manipulate the arm's movements. Now let's move on to the assembly. Secure the cardboard tubes together using the clothespins to form a basic arm structure. Next, attach one end of the string to the top of the arm and thread it down through the tubes, attaching it to the fingers at the other end. The rubber bands will serve as our muscles. Wrap them around the joints of your cardboard arm to provide the tension needed for movement. Pulling the string simulates the contraction of muscles, causing the arm to move. And there you have it. You've constructed a basic robot arm, though without the electronic components that would make it truly robotic. But don't fret, we're getting there. This little project gives a rudimentary understanding of how a robot arm works. Each part of this DIY arm has a real-world counterpart in an actual robot. The cardboard tubes represent the metal links in a robot arm, the string is akin to the mechanical cables, and the rubber bands are like the motors that provide movement. Remember, the key to understanding robotics is to start small and build from there. It's a field that combines various disciplines: engineering, mathematics, computer science, and this basic model is just the beginning. Congratulations, you've just built your very own robot arm, but we're not stopping there. Now that you've built your robot arm, it's time to bring it to life. In the world of robotics, programming is the magical incantation that turns a heap of metal and wires into a moving, functioning machine. The robot arm you've built is no different, but don't fret, you don't need to be a coding wizard to pull this off. Let's start with a simple programming language, like Python. It's as friendly as a snake can get, and it's widely used in robotics due to its simplicity and versatility. Now, think of your robot arm as a puppet, and you, its puppeteer. Each movement the puppet makes corresponds to a command from you. In the same way, your robot arm performs actions based on the code you write. Let's say you want your robot arm to wave. You'd need to program each joint to move in a specific sequence. This requires precision and patience. It's not just about making the arm move, but controlling how fast, how far, and in what order those movements happen. It's like choreographing a dance, where each step is crucial to the performance. And remember, trial and error is the key. Your first attempt might not result in a graceful wave, but more like a clumsy flap. But that's okay. Every mistake is a stepping stone to perfection. Keep tweaking your code until your robot arm waves as naturally as a human. Once you've mastered the basics, you can explore more complex movements. Maybe you want your robot arm to pick up a cup or write a letter. The possibilities are endless, and the more you experiment, the more you'll understand the nuances of programming. And there you have it. You've turned a static piece of machinery into a dynamic performer. You've given it a purpose, a function, and a semblance of life. And all of this with nothing more than some lines of code and a lot of perseverance. You've successfully programmed your robot arm. Isn't it amazing to see your creation come to life? What if your robot could interact with its surroundings? Let's add some sensors. Today we're going to take our robotics game to the next level. Sensors, my friends, are the eyes and ears of our little robot buddies. With them, we can equip our robots with the ability to sense their surroundings and respond accordingly. So, let's dive right in. First things first, you'll need some sensors. There are a lot of different types out there, but for our purposes, a simple distance sensor will do. This will allow our robot to measure the distance between itself and other objects. Now let's get our hands dirty. Connect your sensor to your robot's main board. You'll need to follow the manufacturer's instructions for this, as it can vary from sensor to sensor. Once connected, it's time to power up your robot and start programming. Programming sensors may seem daunting, but don't worry. It's all about telling your robot what to do when it senses something. For example, if our distance sensor detects an object closer than 10 centimeters, we could program our robot to stop, or maybe even back up. To do this, you'll be using conditional statements in your code. Picture it like a digital game of Simon Says. If Simon says there's an object closer than 10 centimeters, the robot stops. Now let's test our sensor. Place an object in front of your robot and see how it responds. If it stops or backs up when it senses the object, congratulations, you've successfully programmed your robot to interact with its environment. Remember, this is just the beginning. There are sensors for light, sound, touch, and even temperature. By combining different types of sensors, you can create a robot that's aware of its surroundings in a variety of ways. Imagine a robot that can follow a light source, respond to sound cues, or even navigate a room based on temperature differences. Your robot can now interact with the world around it, but we're not done yet. The final step in our robotics journey is to make your robot autonomous. And what does that mean, you ask? Well, in the simplest terms, an autonomous robot is one that can perform tasks and make decisions on its own without the need for human intervention. Now, making a robot autonomous is not as daunting as it might sound. It's all about programming the robot to respond to its environment based on the data captured by its sensors. Remember those sensors we added in the last experiment? They're going to play a crucial role here. Imagine this: you've built a robot to water your plants. If you program it to water the plants at a specific time each day, that's not autonomous. That's merely automated. But if you program your robot to sense the moisture level in the soil and water the plants only when needed, that's autonomy. It's making decisions based on data, not just following a preset schedule. So how do you program autonomy? The key here is to create a loop in your code. This loop will continuously check the data from the sensors and make decisions based on that data. For our plant watering robot, the loop might look something like this. Check the soil moisture level. Is it below a certain threshold? If yes, water the plants. If no, do nothing. Repeat. And there you have it. By creating this loop, you've given your robot the ability to make decisions based on the environment, thereby making it autonomous. Of course, this is a basic example. In the real world, autonomous robots have to make far more complex decisions and deal with a multitude of variables. But the principle remains the same. Sense, decide, act. Now it's your turn. Go back to your robot arm and think about what tasks you want it to perform autonomously. Then program it accordingly. Remember, the only limit here is your imagination. You've done it! Your robot can now perform tasks on its own. Let's recap what we've learned today. You've seen firsthand the capabilities of robotics, but where do we go from here? Picture a world where robots are commonplace, assisting us in our daily lives, from household chores to complex surgeries. The future of robotics is a landscape of endless possibilities. In the next decade, we can expect to see advancements in artificial intelligence, which will enable robots to learn and adapt to their environments. We may also witness the rise of bio-inspired robotics, robots designed to mimic the movements and behaviors of living organisms, from the flight of birds to the crawl of a spider. But what's most exciting is the role that you can play in shaping this future. With a little ingenuity and a passion for exploration, you can contribute to this rapidly evolving field. Whether it's building your own robot or developing new algorithms, there's a place for you in the world of robotics. Remember, the future of robotics is in your hands. Until next time, keep innovating and exploring the world of tech.